designing and simulating open loop and closed loop buck converter in MATLAB Simulink. If you haven't subscribed the channel, please subscribe so that you can watch the next video. So how buck converter looks like? This is the buck converter. This is input supply with this switch, diode, inductor, capacitor, and then load. Load may be anything, means resistive DC motor and or battery. So as I showed you previously, input can be battery, solar panel output, or rectifier output, whereas the output could be battery or load like resistive load, DC motor load, it, or rectifier input. Then we have the switch, it can be MOSFET or IGBT, whereas we can use for low frequency normal diodes, for high frequency Schottky diode. The inductor is for the current ripple reduction, and the capacitor for voltage ripple reduction. So this is the basic working of the buck converter. This is for when switch is turned on, and this is for switch is turned off. So when switch is on, the current direction like this, whereas when switch is off, current like direction is like this. So when switch is on, current start rising, whereas at the time of off, current start decreasing. This is the basic formula. Output voltage is equal to D times VDC, where D is equal to duty cycle. So if you want, whenever you want to design the buck converter, these two formula are going to use C minimum, L minimum. You can search this formula at the internet, that how to design the L and C for the buck converter. You will get here the delta IR is equal to ripple in the inductor current, whereas delta V0 is a ripple in the output voltage, whereas FSW is the switching frequency, and V0 is output voltage, D is equal to duty cycle. So the aim we are designing is that we are designing open loop and closed loop converter having input supply is 100 volts. VDC means input supply, and average output voltage should be maintained at 75 volts, means output voltage 75. Whereas maximum voltage and current ripple is 5 volt and 1 ampere. Delta, this is delta V0 and this is delta IR with switching frequency of 10 kilohertz. So using this formula, we got a duty cycle equal to 0.75, whereas L minimum is equal to 1.875 millihenry, and C is equal to 2.5 microfarad. Delta V0 is equal to 5 and delta IR is equal to 1. So in safe side, we took it 5 millihenry and C millimeter. In this case, they are showing the maximum voltage and current ripple. If you increase this C and L, it will reduce the ripple in current and voltage. So that that was the open loop operation. For closed loop, what we will do, we will take the feedback from the output and we will compare with the reference voltage, and then feed it to the PID. PID used to maintain stable and accurate output, whereas PWM used to reduce the losses. So after doing this control circuit, we will feed the output is fed to the switch. So that's how see how PWMs work. This is the carrier wave, means repetitive sequence or circuit wave, whereas this is the generator output of the PID, means this output. So by comparing it, whenever the duty cycle is greater than this the carrier wave, there will be high signal will pass through the switch, otherwise there will be low signal. So what component we will require? For the switch, we will use MOSFET. Input is for DC supply, diode, then inductor or capacitor or output voltage, we will use series RLC branch, then PID, and for PWM, I told you previously that we will use repetitive sequence. Okay, so let's move toward the simulation. Okay, so I have placed all the components here in MATLAB Simulink. So I will explain first open loop and then closed loop. Don't worry about this part, I will explain in closed loop section. Let's see only this part. Okay, so let me remove out this. Okay, let me connect this pulse generator. So as we discussed regarding the component, this is the switch, means MOSFET. and this one is for DC supply. Okay, and then this is a diode, then capacitor of 5 microfarad, whereas inductor of 5 millihenry. Then again voltage measurement, current measurement. These are both are current measurement. This is the load. I took it 20 ohm. You can take anything, miss any value. These are the go-to blocks. These are just connecting blocks. So instead of connecting from this point to this point, I have used go-to blocks. You can search from the here means in Simulink. You can search library go-to. You get this go-to and from block. This is a inductor current, output voltage. This is a main block. You can search it in the library. For now, I took a frequency of 10 kilohertz. This is a display which will show the output. So this is for the open loop operation. Okay, this is for generator having the amplitude of 1. You can take any positive value, 5, 10, like this. The frequency is 10 kilohertz. Duty cycle is 75%. So let's run the circuit. Now, after running the circuit, let's see. You can see the output voltage almost 75 that we want. Current in output current. This is output current and inductor current. Now let's see the waveform. You can see the inductor current waveform also triangular, whereas the output current is almost constant, and the output voltage maintained at 75 volt. Okay, so this was our open loop operation. Let's move toward the closed loop. So remove this one. Okay, so as I told you previously that we will take in closed loop, we will take the feedback from the output. So this is the feedback output voltage. Here is the feedback. Actual voltage is the reference still that we maintain at 75. This is a sum box in PID controller. You can see the PID controller value is P and I. I didn't use the D. Okay. And then output saturation equal to 1 to 0. Then I compared. This is a comparator relational operator. Then this is the repetitive sequence having at 0 output value is 0 at 1 divided by 10 raised to power e. Now 10 raised to power 3 equal to 1. Then the I used discrete time step having value of 10 raised to power minus 6. Let's rerun the circuit. No. So before rerun, just let's connect this PW. Yeah. Okay. Let's try it. Let's see how it works. Since this is reference voltage and this is actual voltage, let's see. You can see that actual voltage is tracking after almost 0.06 seconds. So you can see the output voltage almost 75, whereas this is inductor current and current. This is inductor current, output current, and regarding the how switch is PWM working, as you see, the blue color is our duty cycle, whereas this is the carrier wave. So when blue color means duty cycle or PID output is greater than the carrier wave, there will be pulse, and otherwise there will be zero. So this is how open loop and closed loop operation is done in MATLAB Simulink. So that's all for today, guys. If you haven't subscribed the channel, please subscribe so that you will get the notification of next video. Bye bye.